Liqid software, Liqid OS, implements a composable infrastructure solution. It provides for the management and control of various fabric types, allowing resources to be dynamically discovered, moved, attached, and detached to compute servers on their fabric. Liqid OS is designed to manage PCIe Gen 3, Gen 4, Gen Z, and 3 vendor-specific fabric types simultaneously. Liqid software allows for an efficient and cost-effective use of peripheral devices, as it can be more fully utilized on demand for immediate use rather than remaining idle for long periods unused in a server's chassis. They in effect float from one server to another as needed very quickly. This ability or feature allows us to overcome a server's physical slot and size limitation. The number of devices is no longer limited by the chassis' PCI slot counts and availability. In effect, you can add more devices to a server than the number of PCI slots that it contains. We grow past the PCI slot counts. Now let's do a quick demo. The system that I'm using is configured for PCIe Gen 3. It contains SSDs, GPUs, Ethernet NICs, FPGAs, and several compute servers. So Liqid provides a UI, CLI, and a REST API when controlling or managing the fabrics, the configured fabrics. We're going to use the UI today. And so when Liqid first comes up on a particular fabric or fabrics, it walks the fabric types looking for resources and devices that are visible to it. You can zone in and out certain devices. For example, if you don't want to see Emulux cards and you want to see Mellanox cards, you can zone in and out particular device types. In this case, I have it wide open. So all the devices on this PCI Gen 3 fabric that are visible, it's cataloged here. So we see 2 servers, 16 GPUs, 8 SSDs, 4 NICs, and 2 FPGA device types. Now, these are all in a free pool. There's no notion of separation. They're all available for use. The first container or a way to utilize these devices is in Liqid OS is a group. And a group is basically a way to contain devices and separate them from the free pool or from another group. It gives you a notion of multi-tenancy. So for example, in a company you may have a group for human resources. So we'll create a group, human resources. And that will be our first group. And we can create up to 1,000 groups in Liqid OS. So I'll create another group just to show how easy it is. And this could be maybe engineering. And so now we have 2 groups. And notice the device counts in the groups are shown right here, and there's 0. There's no devices in these groups. So let's populate a group with a set of devices. To do that, you click on the group and you edit it. So we can edit the group. Now, initially, whenever you do a group edit, you see all the devices that are available to the group. And so these are the entire free pool we see. We see our servers, GPUs, SSDs, NICs, and FPGAs. And the group pool is empty. So for this group, we'll move over 1 server, and we'll move over a couple of GPUs, and I'll move over a few SSDs, and I'll move over a NIC, and say an FPGA. And this is like a scratch pad, so you can go back and forth, move things around. As you click on devices, by the way, notice you can see what kind of device it is, the manufacturer, capacity. If it's a GPU, NVIDIA, you can see particular information about a device. So I've decided that this is what I want in my group pool. I hit done. So now I've created this group. Now if we go back out to the system, we notice that in the free pool, these devices are no longer free, they're used. So these are demarcated for use by another group, and they're not really visible to any other group except the owner. And so we see those devices appear in this group. So now, just for a demo, I will edit the engineering group, and we'll move the remaining server to engineering group. We'll give him a couple of GPUs as well. I'll give him an SSD. I'll give him maybe a couple NICs. And I'll give him an FPGA. And we'll hit done. And so now we've successfully created 2 groups. And notice, again, the free pool has shrunk even more. The human resources group has his devices, and engineering has its devices. And everything is separated. So it's secure. Only engineering group can see these, human resource group can see his devices, and the free pool, we could create other groups, and these devices would be used for another group if needs be. Now I can move devices between groups and back into the free pool by editing. So let's do that before I continue on. Suppose I change my mind. I say, you know what? I don't want to have I want to give this GPU to another group, or these GPUs, I don't need them. I hit done. I basically put them back into the free pool. And so those GPUs will appear back in the free pool 2 and 3. Engineering should show no devices, no GPU devices. So they've been moved back in the free pool for use for somebody else. Before I continue on and go to the next stage, I want to just differentiate. We have a notion of a logical view. As you can see, I've been using the logical view. We also have a topological or physical view that actually shows a more connection-oriented depiction of the fabric. And in here we can see, okay, we see our edge devices, and if you have multiple fabric chips, this is a Gen 3 fabric, but you can have multiple fabrics in parallel. We would see a different picture for each fabric type. But in this one, Gen 3, we can actually look at the connections and see information about the connection, utilization, ingress, egress, error counts, etc. per port. So we can kind of get a notion for what's going on the fabric ports. Just wanted to show the telemetry and statistics that we have in Liqid OS. So now I'm going to go back to my logical view, and let's continue on. I've created, we have our free pool, and we have our human resources. Let's continue with the human resources example. And so we've demarcated the devices, and now let's actually use them. So just like when we create a group, inside of a group we have a notion of a machine. A machine is strictly a description of peripheral devices attached to a server. And it's just a container for that attachment information. So I'll create, like in a group HR, maybe there's an employee named Scott, Scott's machine, and we'll create that. And we can create as many machines as we want. We can create up to 1,000 machines in Liqid OS, but maybe this will be Steve's machine, etc. And so you can create machines. Machine, again, just holds a description of devices connected to a CPU. If you have only, for example, 2 or 4 CPUs in a group, you can create 10 machines, and the actual hardware resources can float between the machines. Again, the machine is just it's a way to save the description of connections in Liqid OS, and you can connect and detach devices to and from a machine. Liqid OS actually keeps that connection history of attached, detached times. So you can assemble and disassemble a machine as it appeared in the past. You can say, I want machine Scott to look the way it looked last Saturday or a month ago, etc. So the machine description stays around, and the information of the machine history stays around in Liqid OS. So let's continue on. I'm going to, just like when we edit a group, when we move machines in and out, we have a notion of editing a machine. So we're going to use the edit operation. And notice for my machine Scott, I have all the resources in the group pool at my disposal. So I'm going to take the server, CPU 0. I'm going to add 2 GPUs to this machine. Maybe it's going to do some AI type operations. Maybe we'll have some storage on there as well, and a NIC. So now our free pool has just 1 SSD, 1 FPGA in it, and I put most of my devices in the machine. I'm going to reprogram the machine now. And basically, based on the fabric type of the resources that we're connecting, Liqid OS calls functions and procedures that actually connect those peripheral devices to that server. So we've just successfully completed that operation, and now we've created a machine Scott that contains these devices. Now, this machine is for use for any user now. You can load any operating system on it, or maybe it has an integrated boot drive, or maybe you want to use one of our SSDs as a boot drive. So to do that, let's go to the machine page again. We'll click on it. Oops, I don't want to delete it. No, I don't want to delete it. Let me go back to the machine. And we'll actually load an OS onto the machine, like one of the drives. So remember, I attached SSD 0 and 2. So I can, maybe I want to have a Windows image that I want to put on there. So I basically pick the image and the SSD, and I can install that image on the SSD and make that the boot device. Or I can choose another SSD. That's one example of Liqid OS. If I had multiple GPUs, which I do, connected to this machine, I can enable peer-to-peer on the GPUs, such that when you are doing any operations on the GPUs, the host isn't involved in much of the processing. It's the memory between the GPUs is accessed between each GPU. So that's a feature for when you have GPUs attached to a host to increase and aid in performance. I mentioned earlier the notion of assemble, disassemble. Let's re-edit this machine, and I can show that a little bit more. Let's get rid of GPU 1, put it back in the free pool, and I'll move FPGA over, and we'll, in effect, reprogram this machine. So the machine is being reprogrammed. I should get an event when it's all connected, saying that the operation is finished. And we see that the machine reprogram is finished. So now, if I want to look at the machine history, I should see an attach and detach history of devices. This is a newly created machine, so I don't have much of a history. But I can actually assemble or disassemble this machine and make it look the way it looked earlier in time. So as a machine evolves and you add SSDs, remove SSDs, say you're adding FPGAs during the day and then taking them off, moving the FPGAs to another machine at night, you can say, well, I want machine Scott the way it looked last Saturday. So with this ability, you can actually use Liqid and pick how you want the machine to look as it appeared earlier in time. I'm not going to do that right now. I'm going to leave it the way it is for this demo. There's also a notion of group history and group assemble, disassemble. So if we go back to a group and we click on a group, we notice we also have the notion of assemble, disassemble for a group. And what that means is that if I have multiple machines in a group, suppose I have 5, this is a large fabric with lots of servers, I could have 5 or 10 machines. And I say I want this group to appear as it did last Saturday or 2 weeks ago, and those machines will appear connected as they did at that time. Again, Liqid keeps track of all the machine history, connection information, and all the machines that were in a group at any given time. So we can easily reproduce a group or a machine as it looked in the past. Let's see. What else can I show in this demo? I guess I can show the ease with which you can actually, let's delete. Now I'm going to maybe return devices and resources to the free pool. So I'm going to very easily remove my engineering group. Machine Steve had no devices, so it's very easy to remove him. And now I have Machine Scott. I can edit it, and I could actually move these by hand, or I can just delete the machine, which will auto detach all the devices and put them back into the group pool. And I will delete the Machine Scott that I created. And these are all the devices that I had in my group. I'm going to actually put those back into the free pool. And we see all the devices are returned to the free pool. So Liqid OS allows you to very easily move devices to and from machines, into groups, and back into the free pool very easily. This is Liqid OS version 1.0. 2.0, and we have another release coming out soon, which is has lots of other nice features that I'll show at another time. Thank you.